Hi, I'm Alan Ross. We're here at the RE Plus Conference and Exposition. We're talking to thought leaders about the future of the energy economy. So join us and enjoy. My next guest, Vishal.
Hi, nice to meet you.
Good to meet you. Well, I met you before I met you here, right? So Vishal is with Gamesa, Siemens Gamesa.
Yep.
Which is wholly owned by Siemens Gamesa. This is the most complicated thing.
I will give the straight on that. So I'm the North American Managing Director for Gamesa Electric, which is a wholly owned subsidiary of Siemens Gamesa.
Okay.
And Siemens Gamesa is a publicly listed company in Spanish Stock Exchange, and Gamesa Electric is 100% owned by the Siemens Gamesa, which is our parent company.
Totally separate from the Siemens Energy company.
Totally separate from Siemens Energy, although Siemens Energy owns 66% of Siemens Gamesa at this time.
Okay.
But it is a separate, Siemens Gamesa is a separate publicly traded company in Spanish.
On the Spanish exchange. I want people to remember that because we're going to be talking about things that are going to make people want to buy stock.
Yes.
Okay, because of what you guys are doing. One of the problems that we have discovered, well, we all know this in the industry, and unfortunately, it's your part of that. It's the inverter part of renewables, right? Whether that's solar or whether that's wind. It's kind of the weakest link of that. And it's partly because there's so much going on at the inverter, right? From DC, AC, DC. Talk to me a little bit about the problem before you tell me about the solution.
Yeah, I mean, I think inverter is a product that converts. It's a power conversion unit. For us, what we have learned is that we've got a lot of experience in introducing this product. So the legacy for Gamesa Electric was they introduced the wind converter. It was we have experience in that power conversion technology for last 30 years.
Okay, good.
So when
both onshore and offshore.
And both onshore and offshore, as part of we have introduced that technology. So all the learnings that we have had on the wind side, we have now transferred it for our inverter that we use on the solar market.
Oh, excellent.
So we have one of the highest efficiency inverter on the market today.
Okay.
The lowest harmonics that we can offer. Yeah. So the product that we offer is a fantastic product. Obviously, if it has problems, we have a great service network to service the inverters as well.
Okay. So building a better inverter is one of the first things.
Absolutely.
However, just the nature of what an inverter does creates transients, harmonics, problems within the system. It's now from the utility all the way down to the home. Inverters, I used to say that transformers were the heart of the system.
Yep.
I now say inverters are the heart of the system. Is that probably?
I think that's a fair assessment of what you are saying, and they are, because what we now see is that we need to have a clean power and lowest amount of harmonics. The grid demands it.
Right.
And I think what we've been able to do is, again, leverage our experience, introduce the best filters that we can find on the market to really improve that power quality.
Okay.
And then we are coupling it one of the better transformers in the market that we can get access to. And as a package, I think we are able to really output a really clean power that we can send to the grid right now. So
what's happening is at the consumer side, whether that's an industrial plant or whether that's my house, so much more of what's happening is microtechnology.
Yes.
Microtechnology does not like power quality issues, right?
That is true.
So on the one hand, we're trying to decarbonize and go scale on wind and solar. On the other hand, it creates problems, and no matter how good you create an inverter to be able to eliminate them, they're just growing power quality issues coming all the way down. If I'm making cars and I use these robots, I have to have a transformer at every robot to make sure that it's clean power.
Yes.
Because one, and I got a leak in my car, right? So the problem, you're actually creating the problem by scaling wind and solar.
Yes.
But you're also creating the solution by the inverters you create and then having solutions within it, right?
That is exactly correct, because the focus has always been how do I minimize that problem that you just said.
Right.
So our engineering team does spend a lot of time and effort to really see what we can do to really have a clean power output. And we actually have to spend additional filters and additional resources to really make sure that the power quality that we are providing is not only requirement for the grid in the US, but globally We supply the same inverters globally, and then where we can provide the most grid-friendly power. Our engineering is focused on that, and we try to introduce trying to spend R&D money on that, so we can actually provide the best quality power.
Okay. Solar, you've learned a lot in the wind industry,
Yes.
which is really, I mean, that's a hard industry. Offshore, especially, right?
It
I
is.
mean, you can't just run a mechanic out there every
No.
time you have a problem. And by the way, the problem is usually underwater. So you learned a lot in the wind industry that you say you're now applying in the solar industry. Why is it different, and what is different?
Yeah, so I think the technology is not that radically different. The power electronics, there is a lot we can leverage. What we see on the wind side is obviously the challenges are everything is at a height. So when a turbine goes down, you have to have a really somebody go up most of the time to climb it.
And I'm afraid of heights, so I don't want to be the guy going up that tower.
And that's just on onshore.
Yeah.
And then when you go offshore, you just not only have to go at the height, but you have to take a vessel to be at the turbine.
Yeah.
You have to do so. That's an additional complication that you see on the wind technology. And the wind technology is getting bigger. The turbines are getting a lot bigger. To move them as obviously a logistical challenge that obviously we are trying to overcome. So that becomes the challenge on the wind side. The solar on the side is very much now scalable. Most of the things that we are actually putting in the field is manufactured in the factory, and the assembly that we can do is minimal. Whereas so servicing for solar is a lot easier as compared to say servicing an offshore wind turbine. So those are the major differences. I think solar can be deployed at many places throughout the world, whereas wind, you need to have a very specific wind regime, specific locations where the wind is robust enough for you to spend that capital to
and
deploy.
You don't kill bats.
And then you don't, well, that's...
or bald eagles. I mean, you have a lot of problems with wind that you don't have with solar.
I think even on our wind side, we make sure that the permitting is in place. I think the developers are taking the right precaution to make sure that there is minimal amount of environmental impact. But so I think industry is focused on that. But and then on the solar side, as I said, it's much wider deployable. You can deploy it even on the rooftops. Owning a solar technology is possible for a small player as well as big utilities as well as investors. Whereas wind, you need to have a certain amount of capital to get into utility scale wind.
So let me go to your headquarters are in Spain.
So that is correct. So Siemens Gamesa globally is headquartered out of Spain in Bilbao. And then we in North America, our headquarters is in Orlando. I'm based out of Orlando. And we are responsible for US and Canada market and headquartered in Orlando.
What's the difference? What is happening in Europe? I mean, we know the war is having a greater impact to push everything faster than North America is. Do you see a difference in how renewables are applied in both? Talk about that.
You know, I think it's a good question because what we saw in Europe was a prolific adaptation of, for an example, offshore wind first. That's where it kind of started. Now, I think with the passage of the new Inflation Reduction Act, I think we have come in the North America a long way where we are getting very close to some of the things that we have been seeing in Europe. So there is a greater adaptation of offshore, onshore, and solar storage. So we are seeing what just happened recently, the Inflation Reduction Act, I think is a once in a lifetime opportunity for the industry. We have a 10-year runway where we can now scale and deploy this technology for next 10 years. In the past, you saw that it used to have a 2-year, 3-year extensions, which was stymieing the industry. I think to me, I've been in this industry since 2007. For me, I have never seen such excitement in the industry. We have everything in place, now we have to deliver.
Excellent.
And that's the challenge we have, and our company is focused that to come up with the right strategy to take the advantage of the environment that we see. We need to make right investment decisions. We need to make right product decisions so that we can kind of come to the market with the right products at the right manufacturing locations so that we can deploy.
interesting. The Inflation Reduction Act is a once-in-a-lifetime game changer. You know, the keynote speaker mentioned something about an inflection point.
It is.
That we're at that inflection point.
The hockey puck.
The hockey puck, yeah. Actually, it wasn't going down and then up. It was just going along, right?
Exactly.
Now it's going up. I want you to look even beyond the 10 years.
Yeah.
What do you see for the industry 10, 20 years from now? And I mean the renewables.
Yeah, I think we all know that it's decarbonization age, and it's just going to be, I think we are now at the inflection point where it will start accelerating, and I think we will reach that goal. I'm optimistic, and hopefully we reach it sooner rather than later. Yeah. I also believe that all technologies have a part to play. It's solar, it's storage, it's wind, it's hydrogen. All of these technologies will have a part in play. Electrification of the cars. I think everything will contribute towards this ultimate goal of decarbonizing the whole world, because I think that's ultimately the goal. How do we make sure that we have a globally decarbonized global economy?
Right.
I will also see that a lot of countries are going to get energy independence because of that, because I think everybody can put a lot of renewables in place, and I think that's how I think we will see the acceleration of and change in energy climate. The
world being energy independent country by country. You said one word in there that I have to go back to. Hydrogen.
Yes.
One of our sponsors for this is H2 Scan. They're a hydrogen sensing company, both in processes, so they're in refineries, heavily into transformers, you know, the hydrogen that's formed in a transformer, but they were formed to take advantage of the hydrogen economy.
Sure.
Separate from hydrogen and transformers, how does hydrogen play a part in the future, do you think?
Yeah, no, it's a great question. So I think we are already seeing that in the sense that there are many ways you can deploy hydrogen. You can use that actually to power vehicles as just one of the ways. Siemens Energy, which is our sister company, we are investing heavily in using that hydrogen as a fuel in gas turbines. So we will be powering the gas turbines using the hydrogen as a primary fuel.
A component of it, so it's like partial gas, partial. Okay.
Yeah, the goal is to maximize the use of hydrogen with the minimal amount of natural gas, and then at some point we ideally want to power the turbines with hydrogen altogether.
Okay.
And that's where the trend is. That way, when it actually combusts, your byproduct is water vapor.
Yeah.
Right? And then what we are seeing is that it's the green hydrogen. We will use the solar and the wind to actually generate the hydrogen by water electrolysis. So we are using renewables to generate hydrogen. And then obviously renewables are intermittent, right? So you obviously need something that is a base loaded energy source, which you can then use in something like a gas turbine. I mean, that's where the industry trend is. And we as part of the Siemens Energy, Siemens Gamesa umbrella are focused on deploying these technologies over the next few years.
So you're telling me I should be in the hydrogen economy as my career?
I think it's definitely part of the puzzle.
That was a setup. Anyway, thank you so much for joining us, Vishal.
No,
appreciate it. Good
appreciate
luck.
it.
So all of these interviews that we have conducted have been sponsored by the people behind me. The first one is the Grid Edge Conference and Exposition, which takes place in April 2023 in San Diego. The IEEE PES Grid Edge Conference and Exposition has been a long time in the making. This will be our first one, and it will be a delight. I can already tell you that we've had more papers, more panelists than we could possibly hold, and the conference itself is going to be brilliant. The second organization sponsoring us is H2 Scan. H2 Scan is ubiquitous in the transformer industry as the best. It's kind of like Intel, it's inside. H2 Scan is a hydrogen sensing technology that is patented, that has been around for the last 20 years. It really came on strong as transformer hydrogen became a problem. DGA recognized by IEEE. And I just thank the people at H2 Scan. They are also in electrolyzers, fuel cells, battery storage, but hydrogen safety is incredibly important. They're in refining and processing, so H2 Scan, thank you. Lastly, RE+. We are at the Renewable Energy Plus Conference and Exposition, and as we close this one out, I want to thank them for allowing us to conduct these interviews here, for allowing us to be part of their incredible conference. It's been enormous. Been 27,000 people that have attended this conference, and you can tell the energy, the excitement that's taking place within the renewables industry, so thank you, RE+. It's been a delight to do these interviews, and I hope you've enjoyed them.